Inshallah, in this class, we are going to see the basics and few formulas of complex numbers. Let me start. What is the actually complex numbers is? You see here, in real numbers, we have only positive square root. Suppose we know what is the square root of 4, it's 2. But square root of minus 4 is not defined. Negative roots are not defined in real numbers. So we can write like this, watch carefully. Under root of minus 1 into 4. So we separate this root of minus 1 into 4. Root of 4 is we know 2. This root of minus 1 is defined as I, imaginary. Okay. So root of minus 1 is defined as the imaginary values. So root of minus 1 is denoted by I. So I means root of minus 1. So negative roots are not defined in real numbers. Negative roots are defined in complex numbers. So what is the meaning of I? I is nothing but under root of minus 1, or generally we use I square. I is root of minus 1, but generally we use I square as minus 1. So next concept you see here, what is now the complex number is defined as, or generally is denoted by x plus iy. X plus iy. Suppose denoted by z. So x is called the real part and y is called the imaginary part. So we started here. A complex number is denoted by z equals to x plus iy, where x is called the real part and y is called the imaginary part, where I equals to root of minus 1 or I square equals to minus 1. So like the real numbers here also we have sorry, additive inverse, multiplicative inverse. So just we recall this. Suppose z equals to x plus iy is a complex number, then additive inverse is minus x minus iy. That means we have to change the sign of both x and y. So if you add, you will get 0. So additive inverse means we must get the 0 answer. So therefore x plus iy additive inverse is minus x minus iy. And multiplicative inverse of x plus iy is x minus iy by under root of x square plus y square. So if you multiply these two, we will get 1. So multiplicative inverse means we must get 1. If you multiply this, you will get 1. So multiplicative inverse is x minus iy. Now conjugate complex. This is also used many times. What is conjugate complex is denoted by z bar. Z bar. Conjugate complex is denoted by z bar. So its value is x minus xy. X plus iy's conjugate complex is denoted by z bar x minus iy. Now modulus means its magnitude, its value is denoted by mod z equals to, mod z means modulus, mod z means modulus. So its value will be under root of x square plus y square. It is real square plus imaginary square. We don't take I, just x square plus imaginary part y square. Sometimes we denote this mod z by r also. So r is also written as under root of x square plus y square. Now last is square root of a complex number. We have, when we have to find the square root of a complex number, we use this formula. Under root of a plus or minus ib equals to plus or minus under root of, again under root of a square plus b square plus a by 2. If you are having plus, you write here plus. If you are having minus, you write here minus. For plus, you write plus. For minus, you write minus. I into under root of same. A square plus b square. Here you are having plus. Here you are having minus. Minus a by root 2. Now let me see the relation between Cartesian form and polar form. What is Cartesian form? When we write a point in terms of x comma y, in terms of x comma y, we say that it is, we return the point in Cartesian form. Whereas if the point is written in the form of r comma t theta, then we say it is in the polar form. This is called polar form. This is called Cartesian form. Now let me see the relation. Let me draw a figure. Watch carefully. Suppose we are having this coordinate axis. We take x axis, this is y axis. Now see here, suppose there is a point here p x comma y. So actually this is the y coordinate of the point. This is will be y, this will be y, and this coordinate, this value will be x. This is x, this is y. X coordinate, y coordinate means this length is x, this is y. Suppose in another terms we denote in the polar form. that the point from here, no, so distance from origin is denoted by r. Distance from origin is denoted by r. Distance from origin to the point is denoted by r, and this angle is denoted by theta. This angle made by the this r with x-axis positive direction. So this point is can also written as r comma theta. R means the distance of the point from the origin, and theta means the angle of r with x-axis. So you see, we can say that cos theta, what this is x, no, this is x, this is x. So we can write cos theta equals to x by r. Bring this r here. So x will be r cos theta. In the same way, y will be r sin theta. If you divide this two, you'll get tan. So theta will be tan inverse y by x. So now watch carefully. This is the one thing. No, when we write mod amplitude form or amplitude form, or we say modulus amplitude form, we have to change the Cartesian form into polar form. How? X plus I equals to r into cos theta plus I sin theta. This is called mod amplitude form. This is called mod amplitude form, r into cos theta plus I sin theta, where x is, you multiply this r cos theta and y is r sin theta. Now another thing is theta, we have to take this theta is called the principal amplitude. The angle theta is called the principal amplitude, where angle theta is called the principal amplitude. So how to take principal amplitude? Watch carefully. The principal amplitude is minus pi to plus pi. When we get first quadrant, both positive, we'll get first quadrant. So just we take theta. Theta lies in 0 comma 90 degrees. Suppose theta is acute here. In the first quadrant, we take theta if both are positive. If sine is positive and cos is negative, we go in the second theta, second quadrant. Second quadrant must be taken as 180 minus theta. 180 minus theta. Fourth quadrant, you have to take minus theta. Fourth quadrant, you have to take minus theta. And third quadrant, we have to take minus of 180 minus theta. So for principal amplitude, whenever we get the first quadrant, we have to use theta. Second quadrant, sine positive, cos negative. Second quadrant, 180 minus theta. Both negative sine and cos, we have to take cos. Third quadrant, for third quadrant, we have to use minus of 180 minus theta. And the fourth quadrant, we have to use minus theta. Now see here, cos theta plus I sin theta in short can be written as cis theta. Cos theta plus I sin theta in short can be written as cis theta. Now cis theta 1 into cis theta 2 can be written as cis of theta 1 plus theta 2. Also cis theta 1 by cis theta 2 is written as cis theta 1 minus cis theta 2. Oh no, what is argument? The same as the amplitude. Watch here. Suppose this is x-axis, this is y-axis. Okay. Suppose a point, just now we have seen this is suppose r comma theta. Okay, and let the distance from this is r. Okay, suppose this distance is y x. We know amplitude is theta equals to tan inverse y by z. So sometimes this is denoted by argument z, y by x. Sorry, this is denoted by argument x. Here the x-axis we call this is as the real axis, and y-axis is called imaginary axis. Y-axis is called imaginary axis, x-axis is called real axis, and the plane on which we draw this coordinate axis with x on real, x-axis for real, and imaginary, this is called argand plane. Argand plane means plane where we draw the x-axis as the real part and y-axis as the imaginary part of a complex numbers. This plane is called argand plane. Okay, so here also we have few formulas. Argand of z1 z2 equals to argand of z1 plus argand of z2. Argand of z1 by z2, argand of z1 by z2 is argand of z1 minus argand of z2. Also sometimes we can use this formula, cis theta equals to e power I theta. E power I theta can be written as cis theta. So few more formulas here. See here, if z1 equals to r1 cis theta 1, z2 equals to r2 cis theta 2, Then Z1, Z2, Z1 into Z2 can be written as R1, R2 cis theta 1 plus theta 2. And Z1 by Z2 equals to R1 by R2 cis theta 1 minus cis theta 2. Likewise, the coordinate geometry here also we have the same formulas. For instance, midpoint we have to find midpoint of Z1 and Z2 will be Z1 plus Z2 by 2. Similarly, if we want to find the centroid, then what is the formula? We can use Z1 plus Z2 plus Z3 by 3. In the same way, we can use the formulas for internally division, externally division. Now, last formula is mod of Z1 plus Z2 is always less or equals to mod Z1 plus mod Z2. So these are the few formulas and concepts of the complex numbers. So if you understood this, if you having any positive for you are understanding this, then I request you all to like this, share and subscribe my channel. Inshallah, we are going to continue with the De Moivre's theorem in the next part.